Okay, hi. So I'll be going through MAT 2021 today. And as usual, just the first 5 questions because it's for pure math students. So a regular doctagon is a 12-sided polygon. So you can kind of imagine that you have a circle like this, and then you divide it into 12 different parts. So like this. So each side has around like 30 degrees in total. And so the area of each triangle, since the circle has radius 1, so this is 1 as well. So the area of each triangle will thus be like half times 1 times 1 times sine 30 degrees, which is equals to 1 over 4. And since there are 12 of these triangles, so it's 1 over 4 times 12 of them, which gives you 3. So the answer to this question is E. Okay. So the next problem is something that is so quite classic. I think MAT really likes to give like the kind of integration kind of problems. So as usual we integrate. So this is like x to the power of half plus x squared dx, which gives you 2 over 3 x to the power of 3 over 2 plus 1/3 x cubed, a and 0 giving you 5. So that is like 1/3 a to the power of 3 plus 2/3 a to the power of 3 over 2 minus 5. So you take like you take this bz, so you have like z squared plus 2z minus 15 equals to 0. So z squared, z, z plus 5 times z minus 3 gives you 0. So um, a to the power 3 over 2 equals to minus 5, or a to the power 3 over 2 equals to 3. But I mean, this is not possible because it's in the negative. And so the only case is when a equals to 3 to the power of 2 over 3. Okay, moving on. The tangents to y, e, and x are drawn. Okay, so firstly, we draw the graph. So we know when x equals to 0, y is equals to 1. So the graph will be x equals to when x is equals to 0, y is equals to 1. So it will be something like this. It's drawn at P and Q. So you take the tangent, you have e prime equals to e to the power of x. So for the tangent at this, so this will be y minus e to the power of p equals to e to the power of px minus p. And then similarly for at q, e to the power of q, y minus e to the power of q equals to e to the power of q x minus q. And so they ask for when the tangents cross x-axis at a and b respectively. So when y is equals to 0, you have negative e to the power p equals to e to the power p x minus p, which thus gives you like x minus p equals to minus 1, so x equals to p minus 1. And the other one is x equals to q, no, this is not x, it's a. A equals to p minus 1, b equals to q minus 1. So, um, so the answer is the C. Okay. clear our drawing and move on. Okay, so the area of this region is bounded by the curve y equals to e to the power of x and that. So, I mean, you know what the exponential graph is, and yeah, itself looks like this. And then when x is equals to 0 for this graph, then it crosses the origin. So it's sort of symmetrical over the line y equals to half. So it kind of imagine this, which is not really symmetrical, but can be imagined. So this is a 0 and 1. This is 0 and 0, and they cross each other at half. So since EX is equals to half, then this gives ln half and half. Okay, so then you know that you can take the area of the graph because they want you to find this region this region over here. So you know you can take since it's over the line of y equals to half, you can kind of like transform it downwards. So it's essentially like you're taking two of these when it's like at the x, like after you translate the line of y equals to half into y equals to 0, and it will be about the about the x-axis. So it'll make sense. So it's like 2, 0, it's lower bound, upper bound, ex minus half dx, which gives you 2 ex minus half x, a 0 and ln 2. So that's like 2, 1 minus half plus ln 2 over 2, which gives you 1 minus ln 2. So the answer is B. Okay, moving on. The vector, okay, so well, you let there be x of these, let there be y of this. So you have like x plus 3y equals to 10, and x plus 2y equals to 8. So y is equals to 2, and x is equals to 4. So then it's essentially like you having to choose 4 of these um out of 6 such that 4 of these is this and 2 of it is this. So then it's like you taking like 6, choose 2 divided by 2 to the power 6, which gives you 15 over 64. So the answer is C. Okay, moving on. The tangent to the curve y equals to x cubed minus 3x at a point of A also passes through 2, 0. Okay, so you take the tangent, which is y prime equals to 3x squared minus 3. And so the tangent equation will thus be 3a squared minus 3 um x minus a equals to y minus a cubed plus 3a. And it passes through 2 and a 0. So you sub in 2 here, then you sub in 0 here. So you have 2, 3a squared minus 3 minus 3a cubed plus 3a, which is equals to minus a cubed plus 3a. So then you bring this over to a cubed minus 6a squared plus 6. So, well, you graph it out because it's a cubic. So it will look something like this. Because it has turning points, like, like it's like 6a squared minus 6a. If you let y equals to this, then no, if you let y, no, don't let y equals to this. If you let like y1 equals to that, and then usually in math we try to use different notations so that we don't mix things up. So y1 prime equals to this, where we let it equals to 0, and it will give you a equals to 0 or a equals to 2. So when a equals to 0, this gives y equals to 6, and this gives equals to um 16 minus 24 plus 6, which is minus 6. So oh, which is minus 2. So 6 and minus 2 instead, and hence you can tell from the graph that it's gonna turn somewhere here, and then it crosses the origin again. And then when it's very negative, it goes very negative. So there's like three values of a which satisfies this condition. Because as a turning point that's negative, so it has to cross the x-axis at somewhere that's intermediate. And when it tends to infinity, it goes to infinity. And when it tends to negative infinity, it goes to negative infinity because it's cubic. So thus, it's sort of like this. Okay, moving on to question G. Um, well, I mean, for this, you immediately can kind of tell that it has to be something like sine squared 1 plus cosine squared 1 equals to 1, and this is equals to cosine squared 1. So, I mean, if you sort of like add everything up, and that gives you like 44 of those plus sine squared 45 degrees, which is half, plus sine squared 90 degrees, which is 1. So the answer is D when you add everything up together. Which of the following graphs show this? Okay, so um, usually for this kind of graphs, you sort of just look at like the, I mean, this point seems to be constant for all of these graphs, so it would be good if you could note like how many, say, times that's across the x-axis or what. So when y is equals to 0, so this thing is equals to 1. So this gives you 9 minus 8 sine x minus 6 cosine squared equals to 1. And so this is equals to 6 minus 6 plus 6 sine. And so this gives you 3 sine x squared minus 4 sine x plus 1 equals to 0. So 3 sine x minus 1 and sine x minus 1 gives you 0. So, I mean, this crosses at sine x equals to 1 and sine x equals to 1 over 3. So, I mean, this use like x equals to 90 degrees and x equals to 270 degrees already. And it obviously can't be this because it doesn't look like it crosses that many points. So, I mean, by kind of a, oh dear, oh dear. So, okay, um, 6 sine, okay, so, um, we let this be 1. Let this be minus 6 plus 6 sine x squared, 6 sine x squared minus 8 sine x plus 2 equals to 0. which does make sense. So it does give you this, and you can sort of get that x is equals to when x equals to 90 degrees and is equals to 270 degrees that it crosses like. And I mean it also helps to take the the maximum points as well. So I'll try to consider maximum points of these. So it's equals to 6 sine square x minus 8 sine x plus 3, which is quadratic. You write it in terms of 6u squared minus 8u plus 3, whereby it's like -1. It's bounded between -1 and 1. So you complete the square, and it's like. So when u equals to 2 over 3, which is obviously attainable, there is a minimum point at u equals to 2 over 3. So this gives like two possible minimum points. And if you check that only if you sub this in back, it's like log 2 1/3, which is negative. So you cross out this, you cross out this because it does not give you two negative points. And since it's like 1/3, since u is equal to 2/3, it can kind of guess it sort of like has to intersect it has to have an x value that is like slightly towards the left because um it's gonna correspond to something that is less than 90 degrees. So it's obviously not this because it's too much to your right, and it's not periodic either. So it can only be 8. Okay, moving on. That was a pretty long explanation. So, I mean, usually when tackling problems like this, you look out for one, the minimum point, one stationary, and then the x and x or y, and usually just this suffices alone. Okay, clear, and move on to question I. Okay. So this question's like 237, and then 43, and then so on. Well, I mean, they're asking you to check for n greater than or equals to 1. And you sort of realize that this is equals to 7 times 6 plus 1, and this is equals to 3 times 2 plus 1. I mean, you're not required to do so, but you can find that this actually does make sense by some induction, which is pretty easy. I can do it for you. So, an plus 1 equals to an minus 1 plus 1, which is equals to um an minus 1. Because like an plus 1 is equals to an minus 1, and also on to a0 plus 1. So, I mean, base case is true. And then if you assume that it's true for some n equals to k, whereby you have an equals to an minus 1, an minus 1, minus 1 plus 1. So you consider an plus 1. So it's like, I mean, you just induct. Yeah, you basically just induct to get that this is true. I think it's a pretty classic Math Olympiad problem. But then the induction process is not really occurring to me right now. But I mean, after some algebraic work, you should be able to get that. This thing holds for n greater than or equals to 1. Okay, and move on to I. Okay, so they ask if it has four sides the same length. So like AB is equals to A minus B squared plus B minus C squared, and BC is equals to B minus C squared plus C minus D squared, and so A minus B squared equals to C minus D squared. And so, well, you continue doing this for CD as well, which is equals to C minus D squared plus D minus A squared. And you know that B minus C squared is also equals to D minus A squared. So, well, you can bring this over. A minus B plus C minus D equals to A minus B minus C plus D equals to 0. And similarly, B minus C plus D minus A, B minus C minus D plus A equals to 0. So if you cancel both sides out, you get this is true. Okay, moving on to the last question for Q1. Fortunate. Oh, it's over. Okay. So now they're asking you for a series expansion. So, well, Q2, it's pretty obvious. You sub in X equals to, oh, okay, it's maybe not, it's probably not that obvious, but you sub in like, because you know this is X equals to half. So when you sub in X equals to half, it gives you ln half equals negative half plus whatever this is all in negative. But then this is equals to negative ln 2 as well, so you're able to get this. So you sub this in. And then you use I and the fact that whatever to find the integer k such that this is true. Okay, so okay, so moving on. So we have this like ln 2 equals to half plus 2 times 2 squared plus 3 times 2 cubed plus 4 times 2 to the power of 4. And then you know this is greater than, oh, this is less than this 2 squared plus 3 times 2 to the power of 4 plus all the way. And so it's equals to like 1 over 2 plus 1 over 8 plus um 1 over 24 plus 1 plus 1 over 2 plus 1 over 3, 1 over 8. And you add everything up together and you get that this is like plus 1 over 24 2 equals to 17 over 24 because you gotta use this for this onwards. And so, well, k in this case is thus equals to 16. And I guess it does make sense since like ln 2 is greater than half plus 1 over 8 plus 1 over 24. So this gets to 16 over 24. Okay, moving on. Was I muted? I don't think so. Um, Now for I, show that this is true. Um, Show that this is true, sub in x equals to what half over 2 and deduce that this is true. The bottom is true. So I mean this is equals to ln 3 minus ln 2. So well you use like you add ln 2 at this side, so it's like half plus this thing plus this thing plus this thing. So all the even terms sort of cancel out, and that leaves only the odd terms. It's pretty nice question. Okay, IV deduce that this is true. So I mean, you can also repeat the same way as you did in like II. So you basically use the fact that 1 over 7 times 2 to the power 6 is less than 1 over 5 times 2 to the power 6. And this is also true. So you write ln 3 is less than 1 plus 1 over 3 times 2 to the power 2 plus 5 times 2 to the power 4, 1 plus 2 to the power 2 plus 2 to the power 4, and so on. So this equals to 1 plus, no, this is greater than 1 plus 3 to the power of 2 plus 4 over 3. Oh, it's sort of equal. So it's like 11 over 10. And then again, for this, you sort of just consider the first three terms, you get like 13 over 12. Okay. Justify which one is larger. Um, okay, so since I gave you ln 3, so you take ln for both sides. So it's like 17 ln 3 versus 13 ln 4, which is 26 ln 2. Um, well, I mean 13, 12. You can just use the inequalities derived from the upper one, which is like 16 over 24. Yep, 16 over 24. 16 over 24 ln 2 and 17 over 24. So I guess you multiply this both sides and see what happens. So 13 times 17 gives you 221 over 12, 187 over 10. So it's like 18.7. And then here it's 26. 2 over 3 times 26, which is 52 over 3 ln 2. And 13, 12, 304 over 13. It's like 18.7. And this is somewhat, I think it's smaller. It's definitely much smaller. So 4 over 13 is less than 3, 7, since, well, this is less than 17 ln 3 from the comparing this up, the lower bound of this and the upper bound of this. Okay, move on to question eh, 3. Question 3, yep. Okay, the degree of polynomial is the highest exponent. So, um, turning point at 0, 0. So, turning point at 0, 0. So, P 0 equals to 0 from this itself. And it's pretty obvious. And so, turning point is equals to 0. So, you have like P, as so like you have like um, the equation or turning point equals to 0. So the value of it when it's equals to 0 is 0. I guess this problem, I don't really know why they're asking this as a condition. It seems pretty explanatory from before. So I mean, can I imagine, I mean, you sub it as like some like x to the power of n, a1 plus a2, x to the power of n minus 1, plus all the way until like x to the power of n x plus a n plus 1. And you use like, you sub in 0, and you know this equals to 0, this also equals to 0. So you just take it out as x squared since the smallest possible exponent is gonna be 2. Okay, now for II, a polynomial Rx has a turning point at a0 for some a. So, well, you kind of imagine that you sort of like translate it downwards until it becomes 0, 0. So it's like Rx equals to x minus a squared qx. Because you translate it, translate by positive a So you can derive. Okay. And for III, you are given that fx is polynomial of degree 4, has two turning points at this. Okay, so from the previous question, fx is equals to x minus a squared qx, and also x minus a squared rx, for instance. So the most possible general solve equation will be like a x minus a, whereby a is a constant, and x minus x plus a squared. So describe the symmetry of the graph f x and prove algebraically that there is such a symmetry. Okay, so the symmetry will be a reflection in y. So we check for this by ensuring fx is equals to f minus x. So it's some even function. So you sub it in a x minus a squared, x plus a squared equals to a minus x minus a squared, which is this, and then like minus a plus a squared, which is this. So it is equal. Okay, find the third x coordinate of the turning point at fx. I mean, since there's a symmetry here, and it's only an odd number of roots, so you know it has to be at x equals to 0. Otherwise, it will be an even number of roots. So moving on. Is there a polynomial of degree 4 which exists turning points at Okay, well, for this, like it has a factor of x squared, and then it has a factor of x minus 2 squared. So, is a polynomial of degree 4. So you're like 3x squared, x minus 2 squared. That's the answer. So because like after you verify that this is true, because it's gonna be in the form of ax squared, a minus 2 squared. So you sort of like there's ax4 minus 4ax to the power of 3 plus 4ax to the power of 2, and then you differentiate ax 4a minus 12a plus 8a, eh? 4a 4a minus 12a plus 8a gives you 0, which does fit the condition. So it is a turning point. And you sub in 1, 1 for both. So the a equals to 3 after you sub in 1, 1. Okay. Then they ask you for what happens for IV. Turning point here at x minus 6. Again, you can use transformation. So it's gonna be like x minus 1 squared rx plus 6 as a basis for what you want to do. So you sub in 2 here, you get r2 plus 6 equals to 3. R2 equals to negative 3. And while you sub in 4 over here, and that gives you 9r4 equals to 0. So 4 is a root. So Rx equals to x minus 4. And something else. So R2 equals to negative 3. So it's like x minus b or something. But when R2 equals to negative 3, you have x minus b equals to negative 3 divided by negative 2, which is 3 over 2. So this is 2, and b equals to half. So I mean, you can check everything again. X minus 1 squared, x minus 4, x minus half plus 6. Well, if it's this condition, you look at this. Turning point. Well, it does not fit this condition because when you differentiate this thing, it's not gonna give you this 2 over 3. I mean, I'm gonna verify here, but like 2 x minus 1, x minus 4, x minus half plus x minus 1 squared, x minus half plus x minus 1 squared, x minus half. You sub in 2 times 1 times minus 2. This is gonna give you 6 minus 2, 1 times 3, 3 over 2, and then 1 times 4. 1 times negative 2, which is not equals to 0. So after trying to find this, you realize the answer is no, it's not the correct. It's not gonna exist such turning points. Okay, so Charlie wants a slice of cake, but not sure if this really looks like a cake here. So there is find the area of the slice of the cake in terms of this. Okay, so this is x and this is y, so xy, and then here it's k minus y times x, so it's xy plus k minus y, x divided by 2, just xky divided by 2. I find another point xy on the cake such that by choosing k equals to 1 gives the area of 1. Okay, so this gives you the area of 1, so you choose k x y plus 1 equals to 2. So x equals to y equals to 1 works as well. Oh, but this is the original thing. So, I mean, you can just basically try for anything that works, like x equals to 4 over 3, y equals to 1 over 2 also works. Okay, now you go for question 3. Show that this is possible to choose the value of k that gives a slice of area 1 is xy. Okay, so you know that xk plus y gives you a value of 2 here. If both xy, it's only possible to choose a value of k that gives both conditions that are true. Hmm. So you have to have 0 less than or equals to k less than or equals to 2. So, you know, k is equals to 2 over x minus 1. So when k is larger than or equals to 0, 2 over x minus y is larger than or equals to 0 as well. So 2 minus xy is larger than or equals to 0, which is true. Then k less than or equals to 2, again, you rearrange it. Less than or equals to 2, then you get x2 plus y is larger than or equals to 2. So this is true for both. Sketch the region R of the cake in which both inequalities hold. I mean, unfortunately, in the actual competition, in the actual contest, you probably have to sketch it out yourself. So, um, x, y, less than or equals to 2. So, we consider something that's 2 times 2. So, when this is like 1, 2, this is 2, 1, since it's like a reciprocal graph. And then you have this also. So when you're on top here, it's like half and 2. And when you're at the below here, it's like 1 and 0. So it's something here. And so you're just gonna consider the shaded region in between, and that's R. Okay, let's get a Neonal space. For question V, so he wants to make a straight cut from on top. So let this be like M and 2, and this is like X and Y, and this is like X and 0. So repeating the steps, you get xy plus I Okay, so repeating the steps, you find that the area is xy plus m 2 minus y plus x minus m 2 minus y over 2, which is like xy plus 2 minus y x plus m over 2. So the same thing, you know that you have 0 less than or equals to m less than or equals to 2. So you find that if the area equals to 2, then you have 2xy plus 2 minus y x minus plus m larger than or equals to 2xy plus 2 minus y x. So hence 2 is larger than or equals to x, 2 plus y. And then same thing, consider for 0. Then you're able to get that 0 is less than or equals to xy plus 2x minus 2y plus 2, which you can, Jesus, which you can write. So you get two sets of equations. First, you get this. Second, you get y less than or equals to 6, 2 minus x minus 2. So when you draw it out, you get the area that looks something like this and this. You just have to note the endpoints at y equals to 2, y equals to 0, and x equals to 0, x equals to 2, and so on, if it crosses the region here. So this is R. Okay, pretty complicated problem, but it uses like this sort of like applies the techniques from before. So I guess this is how like MAT questions usually build up as well. Move on. Move on. Okay. Triangular triples. Ask you for F3 is equals to 1, 1, 1. Then I consider F4, realize it's 0, since it doesn't really have anything that fulfills the triangle inequality. Then you have like 3, 3, 3, 1, 1, which does not fulfill the condition. And so you try for 2, 2, 1. And this gives like 3 different permutations. So it's 3. And F6 equals to 2, 2, 2, which again is only one solution. So by showing that this is true, show that this is true. I mean, it's usually when this kind of things, conditions come out, you know that they're probably gonna ask you to induct for the next few prompts. So an A plus B Sergeant C, like without loss of generality, let this be true. Then you know that A plus 1 plus B plus 1 must be larger than C plus 1. And so this basically fulfills the condition already. And since it's larger than C plus 2, which is larger than C plus 1. Okay, now you look at I. If this is a triangular triple equal to an even number greater than or equals to 6, show that it's all. Okay, so XYZ equals to an even number. So you sort of imagine that if one of them is equals to 1 and the other is equals to 1, so the last one can only be equals to 2, because if one of them is equals to 1, oh, what am I saying? Okay, so basically, you realize that if one of them is equals to 1, then the only possibility is that they are all like two of them are all equals. Because if two of them differ by 1, then the triangle equality doesn't add up. However, this gives you an odd number. So none of them can end up in 1. So it has to be at least 2. So then since it's equals an even number, it's at least 2. So you can induct backwards by part I. Oh, I. So since x plus y is larger than z, so x minus y plus y minus y is also larger than or equals to z minus 1, since by since by this even number condition, that is true. Okay, moving on. Using the previous two parts, show that this is true. I mean, you induct forward and you induct backwards, and both sort of work. So given that you have like a plus b plus c equals to 2k minus 3, you know that a plus 1, b plus 1, c plus 1 is also giving you a sum of 2k, but it's also like fulfilling the condition. So likewise, if you have x plus y plus z equals to 2k, you can also work backwards to 2k minus 3 to get the same condition. So you know it's like bijective. And hence, like when they ask for the cardinality of these two, like how many such triangular triples there are, you know that they have to be the same by bijectivity. Okay. And moving on to question 6. P equals to 2s. Mm, okay, so imagine like A is larger than S, then you have like B has C smaller than S, so this already does not fulfill the triangle inequality. So um now you let like A, B, C to be all between like this an S minus 1, so C is equals to 2S minus A minus B, and it's also less than S minus 1, so we can have S plus 1, it's less than or equals to A plus B, and B is also less than or equals to S minus 1. So, so there are possible like S minus 1 to S minus A possible values for B. So you count and you realize there's like S A minus 1 possible values. And then from what A is, then C is determined uniquely from this condition here. And thus the number of such triangular triples is FP equals to, you count like S minus 1, A equals to 2, A minus 1, which gives you S, A equals to 1, A equals to S minus 2, S minus 1 divided by 2. And for question I realized that this equals to F equals to 24. Since this only asks for even numbers, and this gives you 22 times 21 divided by, oh no, it's not 22 divided by 21. Since you're taking like 12 instead. So this is 11 times 10 divided by 2, which gives you 55. And so that's the answer. Okay, I think there are no more questions from here. And so this will be the end of the 2021 MAT class. And thank you for listening, I guess.